Okay, so I want to do this problem for you that involves laws of logarithms because I think it's an interesting problem, but it's a little bit tricky, a little bit trickier than I first realized. So one thing to look at is this first part is not supposed to be calculus. It's supposed to be like pre-calc. You're not taking a derivative or anything yet here. You're just supposed to be simplifying this expression. And then in part B, we'll actually take the derivative. So one thing that's important is to use this hint. The idea that if you square a number and then take its square root, that's the same as taking the absolute value of that number. Okay, they're not exactly inverses because, for example, if you take -2 and you square it, right, we'll get 4, and when we take the square root, we get +2. So it's the absolute value of that. So they are kind of inverses if your domain is just positive numbers, but otherwise we need to use that absolute value. Okay, so for this problem, what we want to do is we want to think about first combining that square root that's showing up here with these exponents. Okay, so think about it this way. We have natural log of x minus 4 to the 26th over 3x minus 7 to the 30th. And then that part is being raised to the 1/2 power. That's the square root part, right? And so actually, maybe a different way to write it would be to put the square roots inside. Because if you take the square root of a fraction, you can take the square root of the numerator and the denominator separately. It's kind of like raising it to a power, right? Raising it to a power of 1/2. So now if we rewrite this as x minus 4 to the 13th squared and take the square root, right? Because we can separate this exponent 26 as being 13 times 2. And the same for the denominator. We write 3x minus 7 raised to the 15th. That's being squared. Now I think it's easier to see that the numerator can be simplified to be the absolute value of x minus 4 raised to the 13th power. And the denominator can be simplified to be the absolute value 3x minus 7 raised to the 15th power. Okay. Now using rules of logarithms, we know that because these are being divided, we can split it up. We can have natural log of x minus 4 to the 13th minus natural log 3x minus 7 to the 15th. And again, we can use this rule that if you have an exponent with a natural log, you can bring it down in front. We're not taking a derivative or anything. This is just rules of exponents. To get 13 natural log x minus 4 minus 15 natural log 3x minus 7. Okay, and this is the answer that they're looking for here. Okay, so if instead of doing this, you decided to take the 1/2 and bring that down in front instead, and then simplify the rest of it, you'll get a different answer. And the reason they're not equivalent, the problem with that is because your answer will only be valid for numbers where x minus 4 is positive and 3x minus 7 is positive. Whereas you can see here that this expression is valid for all real numbers except for, except for x equals 4, because then you're taking the log of 0 and whatever makes 3x minus 7 equal to 0, right? X equals 7/3. Okay, so there's two numbers that this doesn't work for, but it works for all other positive and negative numbers. Down here, if you didn't have the absolute value, you'd be leaving out tons and tons of numbers, right? So if you had just natural log of x minus 4, you couldn't plug in anything that was less than 4. So it would have a very, very restricted domain, and that's why this is the better answer. Okay, now as for the second part, doing the calculus is actually a lot easier now, because now that we have it simplified, the calculus here, when we take the derivative, we'll get 13 over x minus 4, right? The derivative of log x minus 4 will be 1 over x minus 4, minus 15 over 3x minus 7. And then by the chain rule, we need to multiply by the derivative of 3x minus 7, which is 3. Okay? And that will be your final answer for part B.